Okay, so welcome to the first regular session at this year's PHP World. Great to be back, and I have the pleasure to be able to talk to you about Web Performance 2017. So the idea is, let's talk about web performance, but not, a generic web performance talk, but let's look at how the rules and guidelines and best practices for web performance have evolved over the last couple of years, and see what of the advice you'll find everywhere is still valid and which of it is plainly false. So that's the basic idea, but before I actually start, I have to do something. Sorry for that. I never brag, but I'm a two-time recipient of a Donald Knuth check. So I think some of you know what it is. So when he sent me the checks, he kind of wrote, okay, when you speak at PHP Works, please bring one of my quotes. So I said, okay, done, whatever. And so his most famous quote probably is that premature optimization is the root of all evil. Well, that's only like half of the quote, right? So in the next sentence, he kind of, steps back a little bit. But still, so whenever we talk about optimization, one of the crucial points is when do we do our optimization? I originally planned on speaking a little bit about that, but then I saw a couple of weeks ago when I looked at the schedule that at noon there will be a keynote that's called Say Yes to Premature Optimization. So I think this will be a very great keynote, and I'm really looking forward to that conversation. So I will not talk about that. We will talk about that at noon. All right. That being said, there's another person I'd like to quote, because that's kind of my agenda for today. So I assume many of you know Steve Souders. He originally worked at Yahoo and set up the performance optimization team there. And then he moved over to Google, and then he moved over to the startup world. And at every company he was at, he made serious performance optimization. And one of his most famous publication, is actually a set of publications, a set of blog entries. So 10 years ago, he had a series of blog posts that set up 14 rules for faster loading websites. That's what his article series was called. And these blog articles, with some editing, were then later turned into a book, High Performance Websites. 2 years later, a follow-up book was published with several co-authors and more niche topics. But basically, these 14 rules, they are still quoted a lot. There are several tools that also try to assess the performance of your website. The focus, of course, here is front-end performance. And many of them still quote or use those 14 rules. And so what I thought would be really interesting is now, 10 years later, and I mean, in IT, 10 years is, 5 lives or something like that. That's a lot. So 10 years later, what he's created and thought of 10 years ago, is this still valid? Does this advice still hold? Is some of this advice not relevant anymore, or is it more relevant than ever? What is changing? When will it change? And so today's agenda is actually pretty simple. We'll have a look at those 14 rules from 2007. But we will look at it from a 2017 point of view. So I think that should be pretty interesting. So let's go in there right away. And I'd like to start with performance tip number 1. And performance tip number 1 is a very broad one. And it's called make fewer HTTP requests. Okay? Kind of makes sense, right? Because an HTTP request is generally considered as not very efficient due to the protocol. And there are several ways of limiting the number of HTTP requests. Important, that rule is not about the amount of data, it's about the amount of HTTP requests. And there were several techniques in order to limit the number of PHP requests. So a very common technique is combining files, right? If you set up an Angular 5 Hello World application, right? You get about 180 megabytes on your local disk, and a lot of files. And when you then watch that amazing Hello World application in the browser still has to download quite a bit. However, the browser doesn't download thousands of files, only a few. Why? Because those JavaScript files are combined together into one, and also compressed, but we'll talk about compressing later. Another technique that's quite common is CSS sprites. I think you're all aware of what that approach or that technique is, but just in case you don't remember, the idea here is that the overhead, if you have a very small, let's say, icon, the file format overhead counts quite a bit when compared to the very tiny image information. So the idea is when you have a lot of smaller icons on a website, put all of these icons in one big image file, and that image file is smaller than all the small image files combined because there's only one image header. And then use CSS, that's why it's called CSS sprites, in order to always, when you need one of those icons, load the big icon and then crop it so that only the icon you want can be seen. So all of the top websites are doing that. It's a technique that's just very, very common. It's a bit cumbersome, so in the first few years when this technique kind of became very prominent, people tried to generate these CSS sprites dynamically on the server. But yeah, for more or less static content, that of course doesn't make sense. So nowadays, when you have, let's say, a graphics designer that sets up a design for you, then they will also already automatically create those CSS sprites. And one of my one of the most interesting websites when it comes to, let's say, numbers and how web applications are using resources is from the HTTP archive. Actually, something Souders steered for quite a while. Actually, let's have a look at that because there's one thing I'd like to show you. So let's go to httparchive.org/interesting.php. I mean, interesting.php, that's just an awesome URL, but anyway. And so there are some statistics, right, about different aspects, and I think this is my favorite one. Actually, I can increase the size a little bit here. Pages using Flash, we are now at 100%, give or take, no Flash, yes. Okay, finally success, thank you. Yes, I feel the same way. But apart from that, what we also get here, these statistics, they are created twice a month. So tomorrow we get new numbers. So whatever. If I do this talk tomorrow again, then the numbers might be a little bit different, but not much. So this is the number of HTTP requests the average homepage has. And you see here, I mean, 1% of pages have almost 300 HTTP requests, which sounds like a lot, and then you think, okay, something went really wrong here. But I mean, if you look at these numbers here as well, so let's do some math. So 26, 43. So this is 60%. So 40% of websites have over 100 HTTP requests they're doing. That is quite a bit. Now, of course, that's a number that we should consider decreasing a little bit. There are test tools, by the way, which give you information like this, and of course other information. The most well-known one, I guess, is web page test, right? So you enter a website URL. Let's just say, what's it? world.phparch.com. And then you pick out a server where to, test the site from. So I picked a server in Dallas, so very close by. And then we get a lot of statistics, and we might return to those statistics a bit later on. Now, this was kind of the idea from back then, and if you look at those numbers here, then we might get the impression that that rule is still valid and up to date now. And the answer is very clearly a maybe. So as of today, yes, the less HTTP requests, the better. It absolutely makes sense. But what would we do HTTP2? With HTTP2, that protocol overhead, if we have many HTTP requests being sent to one server, is more or less gone, right? So it doesn't matter, give or take, if you have 10 HTTP requests or 1 HTTP request, so the penalty is minimal. However, you do have some effort when you try to decrease the number of HTTP requests and you have, for instance, some bundling mechanism in place, right? So one of the best practices, once we have widespread HTTP2 support, is that all of these workarounds, such as file concatenation and image sprites, as it says here, they ought to be removed. Now is the question, when do we have ubiquitous HTTP2 support? Well, almost all modern browsers do support it. Not all web hosters do support it, right? So that depends a little bit on that. So this is probably, I mean, this is rule number one. So Souders back then thought, okay, this is the key rule. Well, if we have a look at some of the later rules, then maybe the ordering is not always optimal. But this is a key rule, and this is probably the rule that will change the most. So if, let's say next year we meet again, and I happen to talk about web performance 2018, maybe that rule will be almost obsolete. But up until now, as long as there's still regular HTTP in the mix, which I expect, yes, still limiting the number of HTTP requests is a great thing. It's not only the protocol overhead. Another aspect is, of course, that, I mean, if you read the HTTP specification, it says you can only have 2 concurrent requests to the same server. Well, of course, these limitations, they are not implemented any longer on the client. So nowadays you have 6 or 8, sometimes even more, depending on operating system, browser, and device. But still, limiting that is generally not such a bad idea. Now, performance tip number 2, and I was a bit surprised when I read that list for the first time 10 years ago, was user content delivery network. I mean, you know, I was doing these websites for, I don't know, 100 users, maybe even 1,000 users, but not concurrent users. What do I need a CDN for if my audience is limited to whatever, my state or my country? Souders, remember, back then was working for Yahoo, and yes, Yahoo had a need for CDN because of their worldwide audience. And of course, even if you don't have a CDN, you know, per se, in-house for your application, you sometimes are using CDNs. For instance, when loading JavaScript libraries, not from your server, but from a really, really fast server from whatever, say Google, and Google CDN. Also, services like Akamai and others, they are exactly there in order to, well, give your users a great experience for mostly static content. Right? So even now, 10 years later, CDNs are extremely effective. And CDNs are also easier to get nowadays because you don't have to set them up. There are services that provide that specifically for you, more than there were 10 years ago. Right? The one thing that probably has changed a little bit is which CDN to pick. So originally, CDN selection kind of consisted of, okay, here's the IP address. Let's try to map this to a country or a region. Okay, let's just take the first one here in the list. But since we nowadays have a lot of techniques to do real user monitoring called RUM, a great name, by the way, that is very often used to actually determine how fast a CDN is. So many implementations pick one CDN, but do RUM and then try another CDN and then pick the best one as they move forward. But basically, yes, using a CDN is still a good technique. When we talk about these two rules, there's one more, so making a few HTTP requests and using a CDN. There is one thing I'd like to discuss, and that has to do with CDN, so that's why I cover it now. The old train of thought was, have a cookieless domain for your static content, right? Let me tell you one of the let's say anecdotes why this is so important. So Microsoft also once set up their CDN for a couple of JavaScript libraries, and I was measuring this, and others were measuring that as well. And for some reason, it was just slower than Google CDN, and that was a surprise because I mean static files and they have the resources. How can that happen? And so I did an analysis, and then I saw, oh, interesting, that CDN ran under the Microsoft.com domain. So I visited the Microsoft.com domain before, so I had cookies for Microsoft.com that were sent along with the HTTP request, right? which didn't make sense. So eventually they changed the URL to, I think, microsoftcdn.com or something like that. Cookies were gone, and they had a comparable performance to Google and all the other competition. That was the old idea, right? So all the static content comes from a cookieless domain because it's faster. And on that cookieless domain, don't use a fully featured, fully fledged Apache or iOS. Use something really quick and small and tiny and compact, like Lightly or something like that, right? That's still a good idea. However, there is one exception, and that one exception is the main CSS for your website, and that's a pretty important point. Now, because I didn't know how well the internet was working, I've tried loading the PHP World website in web page test earlier today. And here's what was happening. So this bar, hope you can see this, this bar is the DNS lookup, and the orange one is setting up the connection. And then whatever, SSL handshake, and this is where the data is being transferred. And now you see the following thing. You see that there's a DNS lookup, and then Chrome is setting up 2 connections to word.phparc.com. That's interesting because this is when the HTML is being loaded, right? So Chrome has no idea that Chrome needs 2, well, and in practice, of course, many more HTTP connections. The idea is this. If you look at the markup of your average typical website, especially homepage, what is the first resource that's referenced in your HTML? Yeah, it's the CSS. And the CSS is important because browsers wait a little bit before they render a page. They wait for the CSS. Otherwise, you have this, you know, the website looks like Netscape 1995, no styling, no whatsoever, and Times New Roman font all over the place. And then snap, suddenly, you know, the images are there, the fonts are there, etc. In order to avoid this, web browsers wait a little bit because they expect the developer to load the CSS very early. And Chrome does this extra step and opens up a second connection. So once the HTML is there, it just looks for the first CSS file and loads it. Well, it turns out that the homepage of the conference loads a specific CSS for the timetable first, and then just the main style file. I have no idea why. But what I found even more interesting, and I didn't know that before, is that since style CSS is such a common name, Chrome was loading that first, or with the connection that was open first. So pretty interesting, right? So that's super important. So yes, you can use a cookieless domain and especially a high-performance web server for all the static content. But for the main CSS, put that on your actual web server because browsers will open up a second connection to load it, especially for that use case. So that CSS could stay on your actual server. All right, I think that's a pretty important point that is not discussed very often, so I want to tell you that, definitely. Rule number 3 is add an expires or cache control header. So in the expires HTTP header, you provide the expiry date of the resource, right? Because, you know, caching is great from a performance point of view. Caching is horrible from a development point of view, of course. And of course, caching is always my main excuse if someone complains with some applications. Oh, you have an old version in the cache. Let me quickly upload the new one. But basically, yes, we have the expires header, which says, okay, this content expires at that date in the future. And we can also set cache control, whether to cache or not. And I mean, even in 2017, yes, from a performance point of view, everything the browser doesn't have to load via network, but already has on the hard disk is a win. Is a win for us, right? We will discuss other ways of facilitating this caching a bit later on. So now we saw the good way, the expire state, right? So for static files, just some distant state in the future, because I hope your whatever company logo doesn't change every week or so. If it does change, well, then the new logo just has a new file name. So if you're versioning in those file names and still can use caching with a date in the future. Performance tip number 4 is gzip components. And the idea is that a feature introduced in HTTP 1.1, which is now, I think, 18 years old or something, is as follows. So a web browser sends, and all of them do this. And I mean, technically it's a waste, right? Every HTTP request you do adds the accept encoding gzip deflate header. So these are, let me say, maybe 20, 25 bytes that just get sent every single time. Every single time. But the idea is, of course, that the server then knows, okay, this client knows how to process data that is compressed using gzip and deflate. And depending on the web server you're using, there are modules readily available for you to do that. Some of that do that automatically, some of that need to be configured properly. But everything that is not already compressed may be compressed. What is compressed? Well, images are compressed, but that's a different topic, and we'll talk about that in just a few minutes. PDFs files are often compressed. Zip files are compressed. Well, apart from that, you can compress everything. I mean, if you look at HTML, JavaScript, CSS, just the number of different characters you can use in those text files is just smaller than the char set, so they get compressed very, very easily. And if you happen to have a client that does not support this HTTP content negotiation feature, well, exactly that HTTP content negotiation makes sure that those clients get the original files. Yet the number of those clients is maybe as high as websites that rely on Adobe Flash. All right, so yes, that is still true. It was, it made absolutely sense in 2007. In 2017, it's still absolutely true. However, nowadays, you know, we have a lot of magic when it comes to building a website. I know in the PHP space, there is not always extremely much building involved as in other technologies, but still, I mean, we usually have a process for, let's say, bundling files, minifying files, etc., etc. So what you could also do is, when you have static files, do the compression as part of CI or as part of the build. Because then the web server doesn't need to do it, the web server just sends out the compressed files. So for instance, if you use Nginx, there is the gzip static module, and which it's kind of, if you have a file and you have the same file with the gz file extension, and that one is used when content negotiation says that gzip files are okay. So that's how we can compress data, and that's how we should compress data. But let's go back to the interesting statistics. All right, where we are, there we are. And let me bump that up a little bit. So let's have a look at the first chart. Actually, I can increase it even more. Average bytes per page by content type. So the average page has 3.2, I would say, megabytes of data. That's quite a bit, but that's okay. And over 50% of that is images. So we talked about compressing, let's say, HTML, which is about, I don't know, 1.5%, and JavaScript, which is, well, let's just say 15%. So yes, we will gain probably, let's say, 30%. But if we really want to compress content, then images is where we need to start. And of course, when you talk about images, I mean, when I started doing web development, the first thing I learned is that what was the file format back then? GIFs. Yeah, they are compressed, and JPEG are even more compressed. And the more you compress it, the more the quality deteriorates. And PNGs, yeah, they are compressed as well. So do we have a chance to get these 1.8 megabytes or a little bit less down to something? Well, turns out, yes, that's possible, because there are techniques and approaches and services and softwares and modules that tries to still make images smaller without any visible loss of quality. For instance, by reducing the palette a little bit, or if you have an image and you know that that image is only used at a certain size on the website, it tries to compress that as well. This works fantastically well. So just recently we had an optimization project, and it was a website with a lot of images, and they all had to be high quality, and there were a lot of hero images as well, so high resolution, etc. Still, we could cut about 30% of the image size just by running them through those optimizer tools. There are several of them, and they all use a similar approach. What I find pretty interesting from a technical point of view, right? Not from an actual point of view, because most of our images are PNGs, but this ImageMin software here, it's a software library, so to speak. And what that does is, it takes a JPEG, and as you know, when you store a JPEG file, you have to provide the compression value, which is something up to 100%, right? And so usual values are 90% or 95%. And so that software takes the image and then uses compression algorithms and uses values whatever from 95 and then goes down, and just stops when the output image just just looks different, or if you can see the differences, right? So that's actually pretty nice, but it's not super efficient. So I like the other approaches as well. Now, of course, these graphic formats, they are also a decade or several decades old. So new formats are already being developed and possible. For instance, WebP. So if you look at the statistics page again, I think about 5% of websites have WebP content, which is pretty nice. So WebP, new optimized image format. However, there's one problem, or potential problem. Now, when you have an image, of course, that image needs to be displayed, and the graphic chips, the GPUs, or the processors in the graphics cards, they are optimized for the formats we know, PNG, JPEG, etc. They are not optimized yet for WebP, right? So even though that the number of bytes might be smaller when using a new format, still there might be a, whether visible or not, delay in to display, parse and display it, right? There's so much more we could discuss about image optimization. I just put you a few pretty interesting aspects and also in-depth articles here, so you'll get the slides afterwards. I'll upload them to Joind.in. And there you can get more information. The one thing I would like to specifically point out here is the last technique, lazy load images below the fold, right? So if you have a, if you have a long website in the browser, you only see the top half. So that top half needs to be there immediately, and needs to be rendered first, and needs to be loaded first. And once this is done, you can load everything else. For people like me who like to scroll down very, very quickly, that sometimes sucks, but still it's a very useful technique, so use it. Now, we have already talked about style sheets, and style sheets are also the topic of rule number 5, put style sheets at the top, because the earlier they are loaded, the earlier the browser starts rendering. Yeah, that still does make sense. So yes, do this, and what you could also do is flushing, right? So when you send out the HTML fragment for the link to the CSS, you could actually flush it to the browser, so that the browser already starts loading the CSS. And that doesn't, transfer data faster to the client, but the client starts rendering earlier, so the impression of performance is better. The second rule, or not the second rule, the 6th rule actually, but it's the kind of sister rule to this rule number 5, is rule number 6, put scripts at the bottom. Because loading JavaScript is blocking the browser. When the browser is loading JavaScript, the browser is doing nothing else. Why? Because the JavaScript code could inject HTML elements on the page. The browser always loads resources in the order in which they are referenced on the page. Especially important for JavaScript, right? If you load 3 JavaScript files, or if you have 3 script tags, they need to be loaded and executed in the order in which they are on the page, right? So yeah, that's why someone said, okay, since the browser doesn't do anything while JavaScript is loaded, great idea, let's just put all the script tags at the very end of the page, right? Because then the user is already seeing something, and you know, the functionality, the JavaScript, that comes later. That sounds like a pretty nice idea. And I mean, I never felt very well about that, because it's a good idea, but there's one downside. If you load the JavaScript late, JavaScript functionality is available late. And I have here a typical example for that. So I was recording this a while ago. So I'm using Yahoo Mail for, you know, crucial emails, right? Newsletter subscriptions, stuff like that, spam. So I have this kind of workflow, right? So I go to Yahoo Mail, and then I get a list of my emails, and the first 10 emails are spam, newsletter, whatever. So when I see this, I'm already, you know, in my procedure, I click on those mails, and then I click on delete, okay? Now watch me do this. If they let me, now they let me, okay. So I'm going to Yahoo Mail, right? The page is loading, and oops, no, that's not what I wanted. Such a nice video. Okay, page is loading. I still have to pause. Okay, so you see a lot of emails. They are bold, right? So I mark them, and then I click on the delete button on the top. Do you see the delete button on the top? Ah, damn it! It's loaded by JavaScript very late. Okay, could this be a problem? So let's proceed. So I start clicking. Ah, there's the delete button. There is the delete button. I've already selected 3 emails, and now the delete button appeared. By default, the delete button is deactivated, grayed out. And of course, once I select an email, it's not grayed out anymore, right? Sorry for that. Okay. No pausing anymore. Okay. No delete button. I click. Delete button. You see? Nothing happens. I selected 5 or 6 emails. I cannot access the delete button. Right? Because the logic only gets active when I was already active. Of course, I know this. So when I go to Yahoo Mail, I do something else for a minute and then go back and then delete my spam. But still, that's one of these potential side effects. Luckily, 2017, things are a bit brighter than back then. And we have more fine-grained techniques for these situations now. So one approach is to categorize your JavaScript code. What do you need now, and what do you need a little bit later? So for instance, tracking is something that also does, at the end of the page, crucial functionality like event handlers, that should go first. And if there's something that needs to be available immediately, then put it in the head. Also, what we can do nowadays is we can load JavaScript code asynchronously. So if you look at the beautiful diagram here, when you have a regular script tag, right? So the HTML is parsing, sees a script tag, then loads the script tag, executes the script tag, and then continues parsing. So during all of that time, nothing happens, which gives us the impression of a page is slow. But we have script defer and script async. So script defer loads in parallel and then executes the JavaScript once the HTML parsing is done. And script async loads in parallel, and directly after loading, script code is executed. So the parser stops and then continues after the script has been executed. So you could use, depending on what kind of code you want to run or execute, you could use these two approaches as well. And once again, with HTTP2, at least the loading in parallel should be no problem any longer, but the execution, of course, still is. And now comes my favorite rule out of those 14. Avoid CSS expressions. What's that? Yeah, that's an IE feature where you can do JavaScript code in CSS. So you can say width is not 50 pixels, but 10 plus 40. Okay, it's rubbish, so I never understood why this is on number 7. It's slow, I get this, but who is using that? We now have calc in CSS3, but calc offers us a limited set. That's different, but yeah. All right, externalize JavaScript and CSS. Why should we do that? Because then we can cache the JavaScript and we can cache the CSS. Of course, there's some exceptions to that rule. The exception I think we all here know is Google. If you go to google.com and then have a look at the source code, it's all inline style sheets and inline JavaScript. So it's one big HTTP request plus one HTTP request for the logo or the doodle. That's it. But yeah, are you Google? If so, good. If not, externalize your JavaScript and your CSS. Almost all pages, you know, have the traditional setup. We have HTML, we have external CSS, so we can cache it. We have external JavaScript, so we can cache it. Boom, that's it, right? All right, so don't try to be Google unless you are Google. Number 9, reduce DNS lookups. That's pretty interesting. So a DNS lookup, usually doesn't take much time, but as you will see here at the conference, always at conferences, some things on the network take time, and eventually will be the DNS lookup. Now, these DNS lookups, they are cached, and it depends on the browser and also on the browser versions how long they are cached. So one browser that notoriously caches for a very short period of time is Firefox. So if you have Firefox and then you see on the bottom this message, okay, doing DNS lookup, and you wonder, wait a minute, I've been to that page 5 minutes ago. Yeah, 5 minutes ago, but not 1 minute ago. That of course means that those DNS lookups might be a performance penalty if they come at an inconvenient time, right? So the question is, would it make sense to shard our application on several domains? And the answer to that depends on what side you're standing on. If you say, well, I would like to limit the number of HTTP requests anyway, and I know that a web browser is only doing 6 or 8 concurrent requests to the same server, why don't I use just several servers? So the browser can send 6 to 8 requests to server A, and 6 to 8 requests to server B, and to server C. And of course, we also want to have a cookieless domain for static files, except for the big CSS file. So yeah, we could do that. However, then we have a DNS lookup for A, for B, and for C. So eventually, the performance advantage you get is annihilated by the extra DNS lookups. And I mean, of course, technically a browser can send HTTP requests to 4 servers, so we have 32 HTTP requests. But maybe, I mean, you heard at the keynote, right? Only one device in the Wi-Fi here. So yeah, maybe you won't be very lucky with 32 concurrent requests. Yes, several domains can help, but the number of that is a good question. Now, the old rule was that you should shard on 4 domains. And it's not 4 domains because main domains, static files, image files, and something else, but because they did experiments and then they found out, okay, with 4 domains, you get the best performance out of it. Nowadays, the new rule of thumb is more or less 2 domains, because we have more bandwidth, browsers are more efficient, allow more concurrent connections, and so the DNS lookups don't hurt us so much when it comes to performance. However, and that's one important aspect, and the team at Zoasta did a pretty nice study a while back on that. So if you say, okay, you are using more bandwidth, which you do by sharding domains, or which you at least try to do, still that doesn't guarantee a better performance. So they did increase the bandwidth by over 1,200%, but the website itself only got 50% or a bit over 50% faster. And so this is not everything. Sharding on 2 domains is a good idea, and if we use the regular setup, so we have our main domain where all the dynamic content is on, plus the main CSS file, and then we have maybe an extra domain for static files. That's basically the best setup. Once we have HTTP2, sharding doesn't give us any extra advantage. So that rule might then change a little bit as well, so we don't need to shard anymore. However, there's one more approach which I find pretty interesting. It's available in some modern browsers. And I think once this is widespread, this is available all over the place, this might be really interesting. The idea is, okay, I try to, I mean, we have a website, right? We load all of the resources, and once the resources are there, the website is considered loaded and can be used. And we already discussed caching, but there's something in the middle, and that is preloading. And W3C and Web Hypertext Application Technology Working Group, they have specified a couple of, let's say, extensions with regards to preloading. So the first aspect is I do a link tag, rel equals, and then something like preload, DSN prefetch, preconnector, pre-render, and then provide a URL. Okay. And depending on the value of the rel attribute, something different happens. So for instance, if I use a preload, let's use the first example. So with preload, I tell the parser that I need this resource sometimes later on. So the browser can start downloading it in the background if the browser has nothing better to do, right? Yeah, and then that's it. I can do DNS prefetch. Remember, DNS lookup might take some time, but with link-rel DNS prefetch, then the DNS lookup for the host name that's mentioned in the URL is already done for me. Preconnect obviously tells the browser to open a TCP connection to the host. And my favorite is pre-render. So pre-render, as the name suggests, tells the parser that the page that's referenced in the href attribute is likely to be requested by the user. So if you have a look at the statistics and see that 80% of your users, when on, let's say, the home page, click on that specific link, you could put that URL in pre-render, and then the browser downloads that page, downloads all of the resources mentioned on that page, renders the page, executes JavaScript on the page, and fires the onload event. Or the load event and handles the onload event handler. That's pretty nice. So if you've always wondered that on some select websites, you click on a link and the next page is complex, but there immediately, most probably they have been using the pre-render feature. So pretty amazing, but of course, you should be rather certain that the page you pre-render is the page that will be requested, right? Because if you pre-render all of your link targets on your home page, then it might not be as effective. All right, number 10, minify JavaScript and CSS. Yeah, this should be the norm nowadays anyway. There are so many different minifiers. I think my favorite is Uglify.js because I just love the name. You can do this, of course, for external code, and we already discussed externalize all of your JavaScript code. Also from a security perspective. When you come to my session tomorrow on browser security, you'll see why you should externalize all the JavaScript code. And yes, that is still the truth, also in 2017. If you're curious, there is a pretty nice website where you can upload your JavaScript code, and then it compresses the JavaScript code and tells you which of those compressors gives you the best results. That's pretty nice. I mean, I'm not super comfortable with uploading my JavaScript code on some random page on the internet. I mean, if the JavaScript code is on my page, and anyone can download this as well, but still. But if you want to do this, pretty interesting how different sometimes the results are. So I find this pretty amazing. I usually do this with standard libraries, and yeah, the results are sometimes extremely surprising. All right, number 11, avoid redirects. I'm not super sure that this deserves an entry in that list. So the background story that Saudos was telling when he set up that list was that marketing had a campaign, and part of that campaign was, I think, a postcard. The postcard had this, postcards back then, 10 years ago, right? Had this link here, whatever, domain.com/ and then the name of a directory. But a trailing slash sometimes looks ugly, at least to the marketing team. So they just cut the slash at the end because they saw that the website then still was loading. Well, what was happening technically was, since dir here is a directory, we sent this request to the server, and the server sees, okay, there's no file called dir, but there's a directory called dir. So the server sends a redirect request to the client, and the client then requests the same URL again, but with the trailing slash. That's, kind of denial of service, right? Because you do requests when one would be good enough. That's true, but I'm not so super sure how much can be gained by religiously following that rule. But yeah, if you have printed matters or links somewhere, see that there are no redirects, but you get to the final page. Performance tip number 12 is remove duplicate scripts. In 2007, 2 of the top 10 US sites, as determined by Alexa, loaded at least one script file twice. So what I see often is, you have a big company, and the company provides a shell for the website, logo and top navigation, etc., and they're using jQuery. And then one of the branches of the company, they have their own content, and they make some nice application they put on the website. They are also using jQuery, right? So they're loading jQuery twice. Back in the days when jQuery did have different compatibilities between versions, that could be a catastrophe. But even if there's no catastrophe when you load the same script twice, it is executed twice, right? So even if some browsers are caching when they see the same request is issued twice, still the script code is executed twice. So yeah, that rule is not for everyone, because that usually only happens if you have a template and then you do something within the template, but still do this. Number 13. Configure e-tags. Oh, that sounds like a great idea. So we have the e-tag HTTP header, and the HTTP header is sent from the server along with the resource, and it is, kind of an ID or fingerprint or something. So this is a GUID, but it could be anything for that resource. And the idea is this. Whenever the browser requests that resource again, the browser sends the e-tag. And when the server gets the e-tag, the server sees the e-tag, sees the resource, calculates the resource, the e-tag for the current resource on the server, and if they match, then the server just says, not modified, HTTP 304. And if they do not match, so the provided e-tag and the calculated e-tag, then the file is being sent. Sounds like a great idea. That's similar to last modified. The last modified HTTP header, if sent by the server, tells the browser when that URL or that resource was last modified. The browser then sends this last modified date back, and then the server can compare the last modified date. The browser knows still the same of the actual file on the server. If so, the cached version of the browser is still up to date, 304, not modified. Well, we can do this, but what we get then in the end is something like this. So this is the company's website, and there's a lot of JavaScript files, web fonts, JPEGs, and all of this is yellow in the web page test output. Why is it yellow? Because we get a lot of, as I call them, zombie 304s. Right? Since the website was using last modified, the browser, when having cached versions, just was sending those HTTP requests, and all the server did was to say, not modified. We don't have any new versions, including the logo or standard libraries of font that don't change. And of course, that's stupid. right? Do not use e-tags. Do not use last modified. The only thing we should use is the expiry date, right? So if there's an expiry date and the browser has not, and the expiry date isn't there yet, right? So the browser says, okay, it's still in the future, then no request is sent. No request being sent is always better from a performance point of view than one request being sent, even if the answer is just an HTTP 304 with no content. It's a subtle thing, but still, I think it's pretty interesting. When you go to webpagetest.org, what you can do is you get a test result here of the PHP World page, and you see here it took quite some time, right? So there is a lot of data being downloaded here. So some of the optimizations we saw could make sense here. However, one thing that might be important to know, and let me pump up the screen again. Here's under Advanced Settings. By default, you only get the first view. So the page is loaded, and the page is loaded 3 times so that you get like average values. Yet interesting is first view and repeat view. Repeat view means that a browser, so there's like the virtual machine running here, right? You can even test with IE8. The browser is sending a request, and once the page has been loaded, the browser is sending the same request again. But, of course, has a cache. So this repeat view should always be faster because we have the bulk of the application in our cache. So we'll see in a second how that turns out while they are testing. And there's one more performance tip in the set of 14 by Souders. It's called Make Ajax Cacheable. I haven't heard the term Ajax that often in the last 2 or 3 years, right? So nowadays I think we all say JavaScript, what it is. But the idea, of course, is when you have a single-page application, or if you do JavaScript-induced XML HTTP request calls to the server, adhere to all of those rules. If you load content, gzip the content, also JSON backends, especially if the JSON is static, but even if not, JSON can be compressed very well as well because the limited charset. Reduce DNS lookups, well, by default, due to security precautions, we can only talk to our own server unless we're using something like CORS, but still, that's important here. Avoid redirects, etc. Well, and configure e-tags was also specifically mentioned here in that rule, but as we discussed before, no, there won't be any e-tag configuring any longer. All we work with is with the expiry date. All right, so the test is there, and so you see this is the first test result, and that's the repeat view, right? So you see the repeat view is just a fraction of what we have in the first view. So caching works here really well, and we don't seem to have any zombie 3 or 4 requests because then we would have a yellow line. Okay. And finally, still got a few minutes, so one more thing we could talk about at the end is JavaScript optimization. JavaScript optimization is a difficult topic because the JavaScript engines in modern browsers, they are so highly optimized. Advice that was sound and valid a few years ago just doesn't work any longer. So for instance, one of the things, I'll just jump in the middle here, string concatenations. That's super interesting. So there was an advice 10 years ago, very widespread. String concatenation in JavaScript is slow. If you happen to have, you know, a loop that is always adding something to a string. It doesn't really matter if you concatenate 3 strings and that's it. And so what they recommended was, instead of always concatenating those strings, create an array, push all of the strings in that array, and then join that array into a string. Because it's supposedly more efficient. And I found this really interesting, so I wrote a complex test case, right? And yeah, indeed, it was faster, the array. And then a year later, I came back to that benchmark, ran it again, and nowadays the browser was so optimized that my basic string concatenation code was faster than the optimized array joining code, right? So, yeah, always measure what you do, and if it doesn't sound natural, then maybe it's not a good idea. I mean, what generally always helps, thanks to the call chain in JavaScript, is declare all local variables with var, so that it's guaranteed that they are local. If you access some, let's say, object properties or also functions that are somewhere deeper down in the call graph, and try to cache them in a local variable. And one advice that you hear a lot is minimize DOM operations. That's wrong. That's just plain wrong. Everyone says, yeah, working with the DOM costs so much. We only use the shadow DOM and everything is quicker. Well, there is some truth to it, but it's not the absolute truth. And we are here for the absolute truth as much as possible. So, DOM operations are not the problem. Layout operations are the problem. Reading out from the DOM is perfectly fine, but writing might be the problem. So what happens is this. Let's assume we have several DOM manipulations. So we write something in DOM and we write something else in DOM. Browsers are optimized. They let us write and then see what's going to happen. Once we read one of those invalidated properties, then we force the browser to do a layouting phase. Right? So first reading and then all of the writing, if that's possible. But don't do read, write, read, write, read, write, read, write. That is indeed one of those costly DOM operations. But basically, layers operations are key. And as always, if the browser gets an update, your strategy needs to get an update. I mean, I was very brave. I was not very brave. I'm a coward. So I was installing, the new Firefox version that was released yesterday, which is like twice as fast as the old Firefox or something like that. But I was using Chrome here today for the websites I loaded. I just found out. Actually, I wanted to use Firefox, but I completely forgot. Laura Thompson of the Mozilla Foundation, who is also involved in Firefox in that new version, she will be keynoting tomorrow at lunchtime. So please all come. I think this will be pretty amazing. But talking about keynotes, please all come to the noon keynote as well, when we talk about, or not we, when the speaker talks about premature optimizations, whether they are good or not. All right. So we saw 14 different pieces of advice. Some of them were not a good idea in 2007 and even less so in 2017. I just say CSS expressions. Some of them still hold true. Some of them are still true, but there are some additional twists. Think of cookieless domains, with the second HTTP connection being opened before any HTML is parsed. And some of them will change thanks to HTTP 2, including those dear optimization strategies like CSS sprites and maybe even JavaScript file concatenation. So amazing times. I have no idea how this session would look like, let's say in 2018 or 2019. What else is changing? So it's an ongoing development, and I think this is what makes it so amazing to work on web front performance. That's all I got. Please, if you have time, rate the talk. I'll upload the slides there in half an hour or so. Looking forward to all questions, tweets, etc. And with that, I say thank you very much. Enjoy the rest of the conference. Thank you.